That's to say, understanding and control over the way in which new kinds of materials behave. Those sciences drive and are absolutely entangled with processes of industrial, technical, and economic development. I see that. The link between the more mathematical or physical sciences and industrialization is a bit less clear. I think the attaching of very high-class lenses to measuring instruments clearly matters an enormous amount to navigation. It certainly increases the precision with which navigators can move around the surface of the Earth. But the feedback from the new cosmologies and the new revelations of the microscopic world to industrialization, I don't see that at all. So this is the Royal Institution, which was set up in 1799 by a group of landowners during a time when agricultural rents were really high during the war with France. And they wanted, effectively, to feed research back into the basic problems of agriculture. And very interestingly, they thought that the best way to do that would be to set up laboratory investigation of soil chemistry, of the way in which fertilizers work, and so on and so forth. They had already a very strong sense that practical chemistry would feed straight back into economic advance and increased profit. And then attached to the laboratory was a big lecture theatre to diffuse scientific understanding and philosophical expertise to as wide a section of the London public as possible. In laboratories like this one, which belonged to Michael Faraday, we see the way in which, starting with practical investigations in chemical experimentation, you pretty quickly build up a range of sets of expertise in new techniques. This instrument, for example, which is a very fine early 19th century air pump, is designed to investigate what happens when you remove air from an enclosed space, so you can produce a vacuum. Behind us is a whole range of forms of chemical glassware, which are indispensable tools for the kind of practical chemistry that Michael Faraday was doing in the 1820s and 1830s. He was, for example, identifying for the first time a substance like benzene, which, although in Faraday's lifetime isn't turned into an economically significant substance, by the end of the 19th century, benzene becomes the basis of all the new chemical technologies like the dye trades and the explosives industry. So I can see the way in which, in a place like this, you see how practical chemical investigation really drives industrial innovation along and is always entangled with it.